So today's lecture is going to be on inheritance. Now I would assume that you've been seeing inheritance in your other courses, but sometimes inheritance can be a little bit of a confusing topic. The other thing about inheritance is I tend not to use it a whole lot as far directly unless it's a larger project. So that's the other reason that many people don't use it as much as they probably actually realize they are behind the scenes by default within .NET. So what is inheritance? Well, it's just a form of software reusability in which our classes are created by absorbing existing classes, data, and behaviors. So what does that even mean? Well, what it means is that in programming, we need a way to break our programs out into separate chunks so that more than one individual can work on them. And one way we can do this is through inheritance. And so inheritance allows us to take a base class like object. And so if I were to right click on this and go to definition, you can see that someone has written for what it means to be an object in .NET. They have these methods. You can see this public virtual toString method, which we're going to talk about the virtual keyword in just a second. You can see it has static methods, etc., etc. So everything in .NET inherits from the base class object. And because of that, you get all of this for free. So why is that important? Well, in all of our classes, when you're designing out a project, what you want to do is you want to start figuring out if you need to use inheritance by how you architect your program. So what's the top level object? Well, in this particular application, we're going to be talking about a commission employee, because that's in our business here that we're going to create. We have different forms of employee, but all of them are able to get commission. We also have other types of employees that also have a base salary and they have a commission. So there's different types of employee at this business, is what the problem we're trying to solve. And so we're going to use inheritance to help us solve that problem. So with inheritance, our base class is object, and our new class is this derived class is commission employee. So remember, the base class is going to be less specific than our derived class. Well, why is that? Because again, object is very general, commission employee is very specific. And once we inherit from commission employee in a second, it'll make hopefully a little bit more sense. Now, something to understand about C# is it does not support multiple inheritance like C++ does. In C#, you'll notice that there's only ever one object or a base class that your derived class can be inherited from. One and only ever one. Now, in C#, there's something called another concept that called interfaces that will also look like inheritance, and it gives us the benefits of inheritance without actually all the pitfalls of having multiple parents. So you'll also hear some terminology, for instance, something like is a relationship. And so what we can say is a commission employee is a object. Or if you remember our previous example where we created a vehicle, well, we could create another derived class like a car. We'll do that in just a minute, but a car is a vehicle. There's also what's called a has-a relationship, where has-a is where you're actually instantiating an object within another object. So for instance, let's say we had a car object, but within that car object we instantiated a steering wheel object. Well, that steering wheel, you notice that a car has a steering wheel. So it's not deriving from that, it's not in that, but we're using it. Now, a derived class can access all of the non-private members of a base class. So for instance, our commission employee has access to everything that's not private in our object-based class. Now we inherit everything that is private, including methods, but we don't have access to them. We only have access to those that are public or what is called protected. So the protected is this intermediate level of protection between public and private. Most of the time we don't use protected. Generally you should use public properties instead of the protected keyword, but I just wanted to let you know about that. So let's take a look now at this commission employee class that we've created. You can see we've got these two properties, first name and last name, also have a social security number, and then two private attributes, gross sales and commission rate. We've got a standard constructor where a person can pass in all of the data, and we're going to set all of our data. We also have this gross sales method, or property, sorry. So with gross sales, this particular attribute, if the user is going to set this, we're going to want to validate that it's valid. So that's why up here we used these auto-implemented properties, because we were just getting the first name. But for these attributes that we're actually going to set, like gross sales or commission rate, you can see on the set portion, we're actually validating the data. We've also created this public method called earnings. So what does it mean for an employee to earn money? Well, it's their commission rate times gross sales. So that's how this commission employee makes money. So whatever their commission rate is, we multiply that by gross sales. Now in our base class object, there was this method called toString. And you'll notice that they declared it with this virtual keyword. Well, why did they do that? Well, what does it mean to have toString on an object? Well, if you had ever called the toString method, you would see it prints out something like the class name or the method name, something like that. So it's not very helpful of what toString actually does. But maybe we want to give the user, another programmer the ability to say toString on our object. So they could actually say, commission employee, whatever it is, that object dot toString. Well, what does that mean to call toString on our specific object? Well, it just prints out all of the information of that given employee. So if you use that object name dot toString, we're overriding this method, so we're making it specific. The only reason we can override this method is because they used this virtual keyword. So and that's going to be important here in just a second. So now that we've created this commission employee, let's take a look at the next example where we're actually going to inherit it from the commission employee object. So this next example from our book, you can see that we have this new class called base plus commission employee. And we inherit from the commission employee class that we just did. Now if I come over here, this code here, you can see commission employee. As I come down through here, the code is exactly the same. And the thing I want to point out is that this earnings method, see how it's just declared like a regular method without the virtual keyword? Where here we're overriding the toString. So just pay attention to that right there as we go through this next class. So here, what we're saying is oh yes, all of our employees are commission employees. However, some also have a base salary. So see how this is more specific than our generalized base class? And so what we can do is if someone else wrote this commission employee, we can have several of our programmers create these subclasses like base plus commission. Or there may be other ones that are, that's a base plus commission, plus something else or whatever it is, or, sales only. So you can kind of figure out what our base class is, have someone write that class, and then you can have other developers write the more specific subclasses. And what's nice about that is let's pretend that this class is extremely complicated. 1,000 lines of code with very complex methods. Well, if you create this base plus employee derived class, you got all of this stuff for free. So let's take a look now. So now we've got our base plus commission. So we inherit all of this code. So we've got all of this for free. Someone else wrote it, we just inherited it, so we have all of those attributes and methods for free. Now here is our constructor. Now, if someone instantiates our base plus commission employee, that's the object that they're using. But because we get the first name and last name, social security for free, we're still going to have them pass that information into our constructor. But we don't want to have to completely rewrite the base class's instructor. So what we can do is we can use this base keyword. So all of this, just think of all this on one line. I just broken it down so it's easier to read. Think of this as one line of code. And at the very end of it, we just say :base. Because the user passes in this information, and we're just going to call the base class and pass that data up to it to initialize it. And the only thing we have to worry about now is our one new method, which is our base salary. Everything else we can just have our base class taken care of. Now here's a public property for our base salary. We know what properties look like, it just gets and sets here. But we want to override what it means for an earnings for a base plus commission employee. So in a commission employee, earnings is the commission rate times your sales. For our base, it's going to be we need to add on the base salary plus this commission rate times gross sales. And so you'll notice that that's what they do right here. They take the base salaries and they add on the commission rate times the gross sales. Well, let's highlight this. Why is this giving us an error message? You can see cannot override an inherited member because it is not marked as virtual, abstract, or override. So we're trying to override a method that the base class didn't give us permission to override. So as you're architecting a program, these are the kind of things you have to think about. In my derived class, are they going to have more specific methods? And in this case, they are. Now, the other thing is you'll notice that this is our method here, right? So our attribute, so we can access it. However, commission rate, let's come over here again. If we come look at commission rate, you can see that it's private with a capital commission rate property. So over here, we don't have access to the private attribute. We'd have to access the public property. Now we can overwrite the toString method because the base class's object was also with override, but then our base class object was declared with a virtual keyword. Down here, they're just showing you the same thing with that protection level. So let's take a look at how you would actually do this with our next example. And so here's back to our commission employee object. If I scroll down here, now we've added the virtual keyword to the earnings. So we had the foresight to say, okay, I'm creating this general base class. So here's what the earnings is going to mean for all of our employees. But if someone wants to derive from this class and make it more specific, they can now because I used the virtual keyword. And that's the only thing that's really different about that class. So now in my base plus commission, we come down here. Now you'll notice that I can access this base. So that first off, this doesn't give us an error. And now I can call that base keyword again to access the earnings base class method. So if I were to right click on here, go to definition, you can see it jumps me over to my virtual method of earnings for my base class. Now another feature in .NET in our Visual Studio, if you look over here, it has this weird symbol here that has this arrow pointing down. And if we read, it says is inherited. So what it's saying is hey, this method has been inherited by another class. So if I were to click on here, it would show me all the list of them. So I click here, see how it takes me to my derived class? Here you can see it actually would take me back up to my base class. So it's just ways of helping you navigate this inheritance. Now over here, this is where they're actually going to create our base plus commission. Now the var keyword, again, remember this is strongly typed. So if I highlight this, you can see it is base plus commission employee. A lot of times I don't like to use the var keyword, just use the actual name of the class there. Just for me, I like it better. Now down here, here's our employee object, which is of type base plus commission, which inherits from our commission employee. Now, where was this first name instantiated? So if I highlight this, look, commission employee dot first name. So it even tells us that this is actually coming from the base class. Same thing here. See, commission employee dot last name. If I come down to gross sales, commission employee dot gross sales. Here's earnings, base plus commission employee dot earnings. So it's showing you where those methods or properties are coming from. And so this is how we actually use that object. Now, again, the person who's writing this program, all they really cared about was base plus commission. They don't even have to know anything about the commission employee, but they just want to actually now use this base plus commission employee. And again, there wasn't much that they had to write. Again, pretend commission employee was extremely complicated and there's thousands of lines of code in here. You created this one derived class and you added on, right, just 10 lines of code, but you've got all that other code for free. So now you can write your code to get the actual job done. So that's how inheritance works. Now, you'll also notice inheritance with our visual aspects. So let's come over here now and let's take a look at our application that we've looked at before. Now, our button objects, if we were to go into any of these, and let's just actually take a look at our command start button. It doesn't really matter what we set it to. But this command start button, if we were to go to its definition, go to the button, go to its definition, you can start seeing where the inheritance comes from. So for example, here's our button class that we just used, right? You dragged and dropped it, you started setting some properties, but someone had to write what a button was, and they wrote all of this code here. Well, someone first declared a button base. Now this is that interface I was talking about, and we'll learn about that in a minute in another lecture. So if I were to right click on here, go to definition, you can see that someone wrote what it means to be a control. Can you see how this is a lot more general than button base then button. So we're just kind of going up this inheritance chain all the way up to eventually we would get to object. And so we come up here and there's something called component. So I think you kind of get the idea of where inheritance really gains its power from. So again, if the architect at the beginning just wanted to write a button class and that they just had one person work on it, they would have had to write all of this code and no one else could have inherited from control. For example, a label. So a label and button are both controls, but they would have to have the exact same code. So that's where that skills of that architect really comes in handy. So now what we're going to do is we have this vehicle class. And there's a few things that I've changed from the previous example. First off, this model, I've now made this protected, which is again that intermediate level between private and public. And so if you're driving from class vehicle, you have direct access to S model, but again, you probably wouldn't want to do this. You'd want to create actual properties to access that. The other thing that's different here is you'll notice this is a public method. I've added in the virtual keyword. So what does that mean? Well, that means that derived classes of vehicle, for instance, car, which are going to be more specific, can override this method and make it more specific to their needs. So let's take a look at the car. So here's my car. I inherit from the base class vehicle. So I get all of this code for free. I'm inheriting it. Now I add on my own attributes, so spoiler type or has four-wheel drive, again just trying to make it more specific to this class. Constructors are the same. We come down here, I'm adding properties for this given class. Now in my methods, you'll notice that I have this is a public method and I'm going to override it. Why can I override it? Because I used the virtual keyword here. So if I were to delete this, this would give me a syntax error for this method. And you'll notice I'll also have access to the base class for this is a public method. So I can do my specific code, but then still call that base classes this is a public method. So you notice because they have the same name, I couldn't just say this is a public method or else that would actually be recursion. Back over here on our form, go ahead and delete this code back out. We've got this other method here called command create car. So now I can instantiate two car methods. One of them is the default, one is the non-default constructor where I'm passing everything into it. But if I were to right click on this one, go to definition, you can see that I'm using this base keyword to just pass in that other data that the user has given me. I only care about this data specific to the car. Then I've got my car and I can set stuff specific to a car here. I can also call this is a public method. Now, notice when I highlight this, it says clscar.this is a public method. So it's calling the public method that's specific to a car, not a vehicle. So if I do go to definition, you can see here's that overridden method that I called. So that's kind of the basics of inheritance. Now you can see that down here I have this code here that says a car is a vehicle. Remember earlier how we talked about the is-a and has-a relationship? Well, we actually have an is keyword in C#. So you'll notice what this is actually trying to test for. So here's car1 that we instantiated up here. Now car inherits from the vehicle class. So if a car is a vehicle, so is that a true or false statement? Well, it's true, because a car is a vehicle. Now, the reverse is not true. A vehicle is not a car. So it has to work in this order only, because remember, our derived class is more specific than our base class. And so we can use this is keyword to find out if an object is a type of a specific type of object. Now, we'd actually seen this before. Let me go to this tic-tac-toe example that we've seen. And you'll notice that I've got these labels here, and they all call this LBL space click. Well, okay, so if I come over to my method again, they all call this space click. Well, another thing I could have had on this example is I could have had a button that also called LBL space click. And if I did that, then inside here I would have to say, is the sender a label or is it a button? So that's where that is keyword could come in. Now, I don't have to do that here because I know that the only objects that are calling this method are labels, and that's how I can do this statement right here with confidence. But again, if I had different object types, not just labels being passed in here, I could use the is keyword in order to determine if that was true or not. So that's what I wanted to cover with inheritance. So now I want to kind of switch gears and talk about something called in-tier development. Now the reason I'm talking about in-tier development is because we're starting to get into some more complex programming topics like inheritance. And so once we get into those, it's really good to understand in-tier development and how we should start organizing our code. And in-tier is it's one way that you can do things that we've learned over the years that really makes our programs more manageable. And what in-tier development means is that we're going to separate our app out into what are called multiple tiers. And these multiple tiers have discrete processing in each of them. So a typical way that we would break out our program, one of the most basics, is for in-tier development would be 3 tiers, or presentation, the middle tier, and the data tier. So if you just use this very basic in-tier development, now in means it could be in number, so it could be 3, it could be 100. Most of the time 3 or 4 is about the number of tiers that you're going to use. So first let's talk about this presentation tier. So we've done our presentation tier in this class, right? We talked about tic-tac-toe and we designed out the user interface. We had other assignments with student grading where we worked on our presentation tier. Now in our class we've used both Windows Forms and WPF. So that presentation tier is the user interaction interface. So that's what our application looks like. So from there, what does the middle tier do? Well, the middle tier has all our business logic in it. So our middle tier with our tic-tac-toe program, for example, was all of the logic, the wins, the losses, was there a tie, that sort of thing. All of the logic behind our game itself was the middle tier. And that is why in the previous assignment, that tic-tac-toe assignment, I had you break out that code that way. Because in that assignment, we had a presentation tier and we had a middle tier. Now what happened when you closed down the application to the number of wins and losses and ties? Well, they were in memory. They got closed down. That was because we only had a 2-tier application. We didn't have a 3-tier application like we're going to talk about now. So the presentation tier, an important thing to remember is that it accesses the middle tier but does not access the data tier. So what is the data tier? Well, that's where our data is stored. Now, the data tier can be any type of data management system. So it could be a database like Microsoft Access or SQL Server. It could also be a file. And that's the reason that it doesn't matter is because we've put it in a tier. So let's go back to our tic-tac-toe game. We created our user interface. Let's pretend we did it in Windows Forms for this particular example. We created that middle tier, that was our C#. But remember, our middle tier didn't know anything about Windows Forms or WPF or HTML. Right? All the things it needed to process that tic-tac-toe games were passed into it as a string array or booleans, things like that. That middle or that top tier accessed our middle tier. So our UI that was written in Windows Forms accessed, the is winning move from our middle tier. Now we could have also created a data tier on our tic-tac-toe application that saved that data to a file or to a database. And that's how our 3-tier tic-tac-toe program would have worked. So let's pretend we did create that exact. We had a Windows Forms tic-tac-toe program that had our middle tier business logic that accessed a data tier that just wrote the data to a file. Very simple, right? Wins and losses, we don't need a full database or anything like that. Now, let's pretend a year goes by and our customer comes back to us and says, you know what, we kind of want to refresh on this game. We want it to kind of be more polished and look nice. And you say, okay, well that's easy enough. I can now write it in WPF. Well, think about this now. All you have to update is the user interface. So you just change your top tier, change it to WPF. You call all of the same code, right? This could pretend tic-tac-toe is very complicated. Maybe this middle tier had 100,000 lines of code. Not a single line has to change. All that has to change is that pretty presentation tier. That's it. Now the customer comes back and says, yeah, this game's looking great. We're getting more and more customers. But so now we need to start saving away all this data because now we have tens of thousands of people playing our tic-tac-toe game. So now our data tier, just writing this data out to a file is no more adequate. So now we're going to start writing all this data to a database like SQL Server or Oracle. Well, at this point, we've written our presentation tier in WPF, and the way we've written it, it only knows about the middle tier. Well, this application tier, this presentation tier, doesn't know anything about how that data is being served, being saved. It didn't care. So nothing on our presentation layer has to change. Our middle tier, it was being called by the presentation into the data tier, but the middle tier didn't care. It just said, hey, save data. Hey, get data. Save how many wins. So our data tier, we can now change from a simple file system to a complex database, and none of this code up here has to change. Now, if you just would have jumped in and started coding this program and all of the code was behind the presentation tier, then everything, every single time would have to change anytime you upgraded this. Or imagine if you go from SQL Server to Oracle. Now again, none of this, the middle or presentation tier, has to change. You just have to connect to a different database and you're done. So that's where the power of the in-tier development comes in. Now within Visual Studio specific, a lot of times it's good practice that when you actually create your different tiers, create them as separate Visual Studio projects within your solution. And that way you create very specific boundaries in your application. So now let's talk about some of the benefits of in-tier development. So, well, you can scale each tier independently. So back to our database, again, that's kind of what we talked about. We scaled from a file to a database, and maybe even a larger database. So we can continually scale up, and it doesn't affect any of our other tiers. You can maintain other tiers independently. So when you have formal code and it's been formally tested, you know that all of your business logic works perfectly, then later on, if you just touch your data tier, you don't have to worry about retesting the business tier because you can maintain each tier independently. Reusability of code. So let's pretend now our customer comes back to us and says, you know what, this is nice having this Windows application. We'd actually like a web application for our tic-tac-toe game. Well, that's fine. We can now reuse every bit of code in our data tier and our middle tier, and we just have to rewrite our top level tier. We rewrite it in HTML. We can still use our business logic and all of our data tier logic. That's how we reuse that code. And it's much easier to adopt new technologies. So let's pretend the next latest and greatest database, Oracle 2.0, whatever it is going to be, this new Fandango database. Well, all we have to do is update this code down here in our last tier, and none of the rest of the code changed, but we get all of that benefit now of adopting this new technology. So hopefully that kind of makes sense of how our in-tier development has played a role in kind of our earlier assignments, and now you can take this going forward. Thank you.